We just said science begins with careful observation. So let's start with the methods built to do exactly that. The descriptive methods, which capture what's happening without yet trying to explain why. The first is the case study, an intensive, in-depth look at a single individual or small group. Case studies have given psychology some of its most famous discoveries. Patients with rare brain injuries who revealed how memory or language works. People whose unusual lives illuminate something the rest of us share. The strength of a case study is richness and depth. The weakness is obvious. One person may not represent anyone but themselves, so you can't safely generalize. The second method is naturalistic observation, watching behavior unfold in its real-world setting without interfering. A researcher studying playground aggression simply observes children at recess. The great advantage is realism. You see genuine behavior, not behavior performed for a lab. The challenge is control. You can't isolate causes, and there's the risk of observer effects. People, and even animals, act differently when they know they're being watched, which is why good observers try to stay unobtrusive. The third method is the survey, asking many people the same questions to capture attitudes and behaviors across a population. Surveys are powerful because they reach large numbers efficiently, but they live or die by their methods. You need a representative sample, a group that actually mirrors the population you care about, ideally drawn through random sampling, where everyone has an equal chance of being chosen. Get the sample wrong, and your beautiful data describes nobody. Surveys also wrestle with honesty. People misremember and they shade their answers toward what sounds good. That's social desirability bias. And the wording of a question can quietly steer the answer. Notice what all three methods share. They describe, they don't explain. They tell us what's out there and generate the hypotheses worth testing, but none of them can tell us that one thing causes another. For that, we need to start measuring how variables move together and then, eventually, to manipulate them. In the next segment, we take the first step toward causation, correlation, one of the most useful and most misunderstood ideas in all of science.